Hello class. In this video I wanted to go over some of the ideas that we talked about in section 3.3 of our textbook. And those ideas are algebraic properties, three of them that we talked about that we can apply to logarithms. For example, if you have, let's talk about the product property. And the product property says that if you have log of a product of either two variables or numbers, or combination of that you can change that expression to the sum of simple logs, of logs having just one variable. For example, log of uv is equivalent to log of u plus log of v. And about the base here, the base can be whatever. It's just has to be consistent here. The base has to be the same throughout the equation there. Okay? Alright, the quotient property says the following. If you have log of u divided by v, these could be variables or numbers, then you can rewrite as log of u minus log of v. The third property, which is called the power property, says that if you take log of an exponential, that you can simplify that exponential or that log in the following way. You can take the exponent and bring it over and to the side of the log and get n times log of u without the exponent. So so let me show you a couple of examples. Alright, so let me show you an example of three quick examples here. Alright, so let's say that we have log of the following complex expression, x times y squared divided by w. Alright, so in this one example I have multiplication going on, division going on, exponents. So let me show you. This is equivalent to, according to our properties, as the sum and difference of three simple logs. And I say three of them because we have three variables. Alright, so we're going to get log of x plus log of y squared. And we get that because we can see that the x and the y squared are multiplying. It's a product. And then we get minus log w because the w is dividing. Okay, so another way to think of this is that the first two logs, the log for x and the log for y, are both positive, and because they happen to be in the numerator, they're in the numerator, whereas the log of w is negative because the w happens to be in the denominator, which means that it's dividing the overall expression. Alright, so now, can I do anything more with this expression? The answer is yes. The middle term is y squared, and according to the power rule I can bring the exponent down. So, final answer, bring the 2 over, and we get these three simple logs. Alright, let's go on to the next example. Next example is log of the expression x all over w2, y2. Alright, now we have three variables. We're going to have three simple logs. Alright, the x is in the numerator, so we're going to have log x, positive log x. Now the w is in the denominator, which means that it's dividing the overall expression. So we're going to have 2 log w, or minus 2 log w, because the w is below dividing. This is minus again, alright? And then the y squared is going to yield minus 2 log of y. The reason, because although the y is multiplying the w, the y is actually dividing the overall expression because the y is in the denominator, in the bottom. All right, so then that's the answer to that. So we expanded this complex fraction and the log of that fraction into simple logs. All right, and then finally C, example C here. Here I have the natural log x to the fourth square root of y all over w squared and the cube root of z. Okay, well, I see 4 letters here, 4 variables. I can simplify it. The sum and difference of 4 natural logs, simple logs. All right, so we get 4 ln x. The first log is that. It's positive. And then if we remember from earlier in the school year, the square root is the same thing as an exponent of 1/2. So we're going to have 1/2 ln y. All right. Now, the other 2 variables are in the denominator. So I'm going to have to use negative logs. All right. So let's start with the w2. That's going to yield negative 2 ln w. And then the cube root for the z is the same thing as power 1 over 3. So minus 1 over 3 ln z. All right, so that's expanding the logs. Expanded them with the properties up here. All right, now the other thing that we talked about in class regarding these properties is being able to go backwards. All right, backwards. I give you the sum and difference of the simple logs, and you give me the single log. And let me bring this over here. All right, and let me discuss this. All right, so in this other example, we're doing the opposite. It's called condensing. All right, so I have 3 logs that are added and subtracted, and we're going to convert it into just a single log. All right, well, so the log is going to be the natural log, and then inside the parentheses here, the x is going to be on top. The w squared is going to be in the on top as well. Why? Because ln x is positive and 2 ln w is also positive. Both of these are positive. That's why they go in the numerator. Now the y is going to go below because this is a negative natural log of y. All right, and once again, this is called condensing, which is going backwards. And we talk about these ideas, these properties, because later in the unit, we're going to be using these ideas to simplify equations when we do applications using logarithms and exponentials. Okay, well, that is all on this